Question 5b. Let g of x equal e to the 2x minus 8 e to the x plus 7, where x is an element of the set of real numbers. The function g of x has exactly one stationary point, and which is a local minimum. Find the largest value of a such that when g is restricted to the domain from negative infinity to a, including a, it has an inverse function. There are a few things we need to clear up before we move on. First, the function has one stationary point, which is a local minimum. And second, we need to restrict the domain so that the function has an inverse. So why we need to restrict the domain? Because to make the function have an inverse. Before we start, we can sketch the graph like this. This is local minimum, and this is just a rough sketch, but it gives us right idea. Using horizontal line test, we can see that the line intersects the curves at 2 points. Therefore, this is not one-to-one over the entire set of real numbers. However, by restricting the domain, like this, we can see that it now passes the horizontal line test. You can see that. So let's find the point. This point, a stationary point is a point where the derivative is 0. So g prime of x is 2e to the 2x minus 8e to the x. And we can factor out 2e to the x from the equation. So 2e to the x, e to the x minus 4 equals 0. According to the null factor law, for the product to be 0, at least one of those factors must be 0. So 2e to the x equals 0, or e to the x minus 4 equals 0. But an exponential function e to the x is always positive. It's always positive. So it never reaches 0. This part can never be 0. Therefore, the other factor, e to the x minus 4, must be the one that equals 0. So x is log base e of 4. So we restrict the domain from negative infinity to log base e of 4. So it looks like this. But so log e of 4 is a, but you can set the point A this or this. But the question asks us to find the largest value of A. So A must be log base e of 4.